Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and exercises are published to our website aws-dojo.com. Today, I'm going to talk about Amazon EMR, which is absolute beginners level tutorials. That means if you know nothing about Amazon EMR, this is a tutorial for you. So let's get started. And I will use the same format I use for my other videos. So first we will talk about Amazon EMR and then I will provide you a workshop which will give you set of instructions to do some hands-on with EMR. So why you need Amazon EMR? Many times you have a requirement where you have to process large amount of data, whether you want to clean the data or you want to transform the data or you want to aggregate the data to create some kind of data model or you want to do machine learning. And when you have a requirement for processing such a large amount of data, generally you use some kind of big data frameworks. The frameworks which are designed to do this kind of large amount of data processing in a fast, accurate, and efficient way. And many such frameworks are like Apache Hadoop or Apache Spark, which work with open source projects like Apache Hive or Pig or Spark to do processing of large amount of data in a very efficient way. So if you have a requirement for processing large amount of data and you want to use big data frameworks like Apache Hadoop or Spark, then you use Amazon EMR, because Amazon EMR provides you a managed cluster platform, which is an environment which you can use to process large amount of data. And it is called a managed cluster platform because this cluster is managed by AWS, and this cluster you can use with big data frameworks to process large amount of data in a fast and efficient way. So what exactly is this managed cluster platform? How does this cluster platform look? So let's talk about that. Let's get a bit deep and talk about how does this cluster look like. So this cluster has got three types of component. Okay, you have one master node, at least one master node, and you have got one or more core node, and none or more task node. Now these nodes actually are, you can say, they are certain softwares which are running on EC2 instances. So master node will have its own software running on an EC2 instance. So will be your core or task node, which are certain specific softwares which are running on EC2 instance. But this master node, core node, task node, these EC2 instances are called EMR cluster. Cluster because there are more than one EC2 instances which work together to give you this big data processing service. So what exactly this master, core, or task node exactly do? So you're starting with the core node. So your core node are the EC2 instances where you do actual data processing. So you want to do a large amount of data processing. You might want to deploy, say, 4 core nodes, 4 EC2 instances, which you want to use with big data framework to do certain data processing. And this job of doing the data processing is done on the core node. Core node can also store your data which it is processing. Now there are certain nodes which are task nodes, and task nodes are a lot similar to core node in terms of they're also used for doing the actual data processing. But the difference is that task nodes cannot store the data. So nature-wise, core node and task node are same type of nodes and they have same type of job, that is to do actual data processing. The difference is that core node can store data but task node cannot store data. Now, there could be more than one core node and more than one task node. Okay. Now, you need someone or something which can orchestrate these nodes, which can manage these nodes. And that is the job of the master node. So the master node is kind of a ringmaster who is doing distribution of the task, distribution of the data among the nodes. It will also track the progress of the task, status of the task, and also takes care of the monitoring of the health of the cluster itself. So the master node is kind of a leader node, kind of an orchestrator node, whose job is to make this core node and task node work together in order to process the data. So the master node is an orchestrator, and your core node and task nodes are the actual nodes or EC2 instances which actually do the data processing. Okay, so that's how your cluster look like. So the next question comes that, okay, so suppose you have got an EMR cluster, then how do I submit my data processing job? I mean, looks like cluster node is a more of a collection of it's like infrastructure where I have got a master node, core node, and task node. How do I submit job to this cluster? Job to a cluster is and when I say job, it is a data processing job, the big data processing job you want to do. So job to a cluster is submitted using something called EMR task. So EMR tasks are submitted to Amazon EMR cluster, and this EMR task has the business logic, you can say, to do certain data processing on certain data. Simple. So how many ways I can create this EMR task? There are many ways you can do that. So for instance, you can go to AWS Management Console and can submit your task from the Management Console. And this is something, in fact, I will show you in the workshop as well, where you will submit a data processing task from the AWS console. But you also have a choice to use EMR API or AWS CLI to submit the same task. So the same EMR task can also be created and submitted by EMR API and CLI. So again, if you're supposed you have built some kind of application, and from there you might want to call EMR API to submit a task, you can do that as well. Or you can go to the console and can use AWS CLI to create and submit this task. What else? You can also actually log into, or you can SSH to the master node, not I think there's a typo there, it should be node, not node. So you can SSH to the master node and you can submit task there as well. It's similar to AWS CLI, but you are actually going to the master node and then you're submitting your task there. So you can do that as well. Other than these three methods, actually you can also launch a Jupyter Notebook. And through the Jupyter Notebook, you can also not exactly submit the EMR task. Well, you can submit the EMR task, but actually you can work more interactively with your Amazon EMR cluster to see the data processing. So since your Jupyter Notebook is interactive, where you can do, like, you can really run your script or your business logic line by line and see the execution, it is mostly used for the development purpose. So in your development environment, you can use Jupyter Notebook to write your lines of code or script, which is doing the data processing for you. But the other methods are used in the production environment. So if you want to run your task, if you want to submit your tasks for the production environment, then you should be using some of the other three methods. While in your development environment, you can use Jupyter Notebook to work more interactively with your EMR cluster and do the data processing task. So these are the methods you can use to submit your data processing task. Now the question comes, how does the task look like? So good, fair enough. Now I know how to submit the task, but how does this task look like? Actually, task has got two parts. And one part is that you write a program. Actually, you write a code which does the data processing. And these code you write into programs like Spark or Hive or Pig. There are many others. Yeah, I just named few here. These are the programs you use to actually create the business logic of the task. And I'll show you a few examples, then it will start making more sense. And of course, you will also in the workshop do such task creation. So again, you'll get hands-on experience. But try to understand, EMR task has got two parts. One part is where you write your program, your business logic, and that is done in languages like Spark, Hive, or Pig. So just to give you an example, for instance, Spark, what I'm doing over here. So what I'm doing here is that I am importing some Spark libraries, PySpark libraries. Then I am establishing the session, and in fact, I'm getting the session, Spark session, and then I'm trying to read some data from a CSV file, stored into S3 bucket, and I'm populating that to a data frame, and then I'm doing a simple transformation in this example where I'm simply selecting only these two fields out of the data frame, and this transformed data frame I'm writing in a Parquet format to another S3 bucket location. So this is a business logic, probably pretty simple one, so it doesn't impress you much, but yeah, you can also build a very complex business logic. So you build a business logic like this in order to create a task. Another example I'll give you, which is from the Hive. So like in this case, you're creating a kind of schema or external table, okay, which is reading data from, in this case, a DynamoDB table, okay, and then you are doing some column name mapping over here with the DynamoDB, and then once that is done, you are writing a SQL query to create a data set, which is doing some group by and filter condition. Yeah, again, a simple example, but just to give you idea how the syntax look like in Hive. So one of the things, if you want to use EMR, which you have to learn, is that you should be knowing some of this Spark or Hive or Pig frameworks or programs, so how to write business logic in them, because they have their own programming language, their own syntaxes, their own way of creating data, writing data, processing data. You need to understand that fundamentals, okay? And that is something which is outside AWS. You have to learn by your own. You can Google it, find hundreds and thousands of resources, and can learn from there. But coming back to the EMR, the first step of the task is to create a program like that in the choice of the program, Spark, Hive, Pig, you decide, okay? Once you have defined the business logic, then comes the second step. And the second step is to configure and run this business logic. And that you do by configuring a task. So first you define a business logic, now you configure a task which will run this business logic, and this is an EMR task I'm talking about here. How does it work? In this example, suppose this PySpark code we written. So we written the PySpark code. We zip this PySpark code, and then we upload it to the S3 bucket over here, and then I'm simply configuring the task over here, where I'm saying that, hey, I'm taking the I'm running a custom jar. This is the jar I'm going to use, which is an out-of-box thing with AWS. I want to submit an Spark task where my source, my code is in this Python file. So in fact, you don't need to zip this one. So my code is in this Python file. Yeah, this is my source, and this is my destination. And I'm giving again one example. It need not to be exactly in the same number of arguments or syntax. So just an example that you first write your program, and this is an example of where I'm using a PySpark based code. So it's a Python program for the big data processing, and then we configure and run the task. So this is how the task look like. And when you run this task will then use the EMR cluster to do the big data processing. Now, the example again I showed you a simple example just to keep it simple for the beginners, but you can have very complex business logic built into Spark or Pig or HBase to do a very complex programming as well. So, having understood the task, the next thing is how do I automate the task? So, fair enough, I learned that I want to. I can create. I can create the task. I can launch from the console, from the API, from the master node itself. Now that is a manual thing, right? So how do I automate this task? Now automation of task depends on how you want to run the task. So one approach could be that you want to run the task based on the events. So things like this, for instance, your data comes to DynamoDB or S3. Again, I'm giving one example, but there could be more data sources. So data coming to S3 or DynamoDB, which is raising one event, and you call a Lambda function on the triggering of the event, and that Lambda function will simply use this submit task API to submit the task. Yeah, as simple as that. So you can configure this kind of event-based model where you submit a task to the EMR when the data gets populated or updated in the source system. This could be one approach to automate the task. The other approach could be based on the schedule. So suppose you know when your data gets published, or you know that there are certain data sources who don't support events. So in that case, you have to probably rely on a schedule-based automation of the task. So just to give an example, in this case, you will use, say, Amazon CloudWatch, and in that you can create a rule for the schedule. And for this rule, you say my target is a Lambda function, and that Lambda function will simply use submit task API to submit a task to the cluster. So second approach is your schedule-based approach, where you use CloudWatch and Lambda function to submit a task to the EMR cluster. And you use this kind of approach when either your requirement is to run based on a schedule, suppose you want to run once per night, or you have a data source which does not have an event mechanism, and in that case you have to rely on the schedule to run the task. So this is how you automate the task. So going forward, so what if, okay, so far looks good. I can run a task, I can automate the task, but what if I have multiple tasks? I have a complex business logic where I do one big data processing with a task, then the second processing, then third processing, and so on and so forth. How do I do that? In that case, you have to rely on step function, AWS step function. And AWS step function has a direct integration with Amazon EMR, which means that you can configure EMR task in your step function to create a very complex workflow to run multiple tasks in an orchestrated fashion. So literally, you can launch your cluster, then you can run your task, then second task, third task, check condition in between, and those kind of things. You can really build a very complex business logic which can orchestrate multiple EMR tasks in an orchestrated fashion. And that you can easily achieve with AWS step function, which provides direct integration with Amazon EMR. So moving on. So we understand how to orchestrate multiple tasks. So far we talked about, running a task, launching a task. How does it work with Jupyter Notebook? So you can launch a Jupyter Notebook, and as I mentioned earlier, the Jupyter Notebook can be used for very interactive programming with the EMR cluster to in fact, it is primarily used for development because it is very interactive. You can check your business logic, you can do your unit testing and those kind of things. And And let me show you how it looks actually. So for instance, you launch your Jupyter Notebook, then for instance, the same code I showed you earlier, I'm running it over here. So first I import the library, and you can see how interactive it is. It's saying that, hey, my Spark session has been created. Then I run the next code, which is getting the Spark session. And then the third code is where I'm actually running this code to load the data into a data frame. And finally, in this example, I'm checking the schema of the data frame to see how does my data look like, which I just read from the source data. So you can see that you can use Jupyter Notebook to work with EMR Cluster to program in an interactive way, mostly for your development environment. And that's how your Jupyter Notebook works. So having learned the Jupyter Notebook part, let's talk about how does EMR stores data. And there are actually two choices which EMR has. One is called your SDFS, which is a distributed and scalable file system, which actually stores your data across multiple instances to speed up the job and also to avoid the loss. It is, by the way, an ephemeral storage. That means if you kill your cluster, if you terminate your cluster, your data is gone. So the data is live, data is stored as long as your cluster is up and running. And because on the termination of the cluster, it kills itself. It is primarily used for caching or storing the intermediate results during the large data processing. Now, the other storage which EMR file system has is called EMR file system, or EMR FS. And basically, what AWS has done, that it has extended the Hadoop to have a direct access to Amazon S3. Now, in this case, the data is stored into Amazon S3, and it provides, since data is stored into Amazon S3, it gives you a persistence storage. So even if your cluster has terminated, you don't lose your data because your data is stored into S3. The thing is that in an EMR cluster, you can either use SDFS based, or you can use Amazon S3 or EMR FS based storage. Now, from the best practices point of view, what people do is generally people use SDFS because it's really very fast, and it is and it's distributed. And then what they do is that they used SDFS for all the intermediate results or caching of the store, but for the data which they want to store permanent and persistence, even if the cluster has died, that data they store into S3. So either they can that data could be an input type of data, that data could be an output type of data. Any data which you want to persist, you put into Amazon S3. And when I say Amazon S3, I'm not talking about EMR FS, because remember I told you EMR FS and SDFS both cannot be together into one cluster. Okay, so you have to choose between these two. So what many people do, they choose SDFS and they use Amazon S3 service itself. And they use Amazon S3 service to keep any kind of input and output data which they want to keep for the longer time. They want to keep it even when the cluster has terminated. And they used SDFS for any kind of intermediate result. Okay, so that's how EMR storage works. So let's also go through some of the important cluster configuration. The first one is software configuration. So as I told you, I mean, when you are running a big data processing, you use certain frameworks, you use certain programs to run your business logic, to create a business logic and run your big data processing. Now you have a choice, so you can really choose. Like I have shown you a list of softwares over here. You can choose TensorFlow or for machine learning, or MXNet for machine learning. You can use HBase or Presto or Flink or Levy or Spark for big data processing. So depending on what what program you like to use to build the business logic. When you are configuring your EMR cluster, that software you can choose. And when you do so, your EMR cluster will be launched having those software deployed on your cluster so that you can simply start programming with it. Okay, that's the one very important thing to do. Now, it might happen there are certain softwares which are not available in that list over here. And one very good example I'll give you is AWS Data Wrangler, which can be used actually to work with pandas data frame. And you can see in the list over here, AWS Data Wrangler is not in the list here. So what if I want to deploy AWS Data Wrangler? In that case, what you do that you can actually you can provide some software configuration, and then you can provide a bootstrap script to install these softwares on the cluster when the cluster starts or when the cluster is launched. So you can configure a bootstrap script into your cluster to install any kind of software you want to install on the cluster, which is outside the list I showed above. So again, it enhances your software configuration and helps you create an environment in your EMR cluster which you can use for your specific needs. So moving on, having understand the software configuration, you also need to provide network configuration, and it is very important because sometimes you work with databases, like your data could be a data into some kind of external relational database, or it could be running into Amazon RDS, or it could be data stored into Redshift. And in that case, your network path to your database is important. Your cluster should be able to connect to your data source. Okay, so in that case, this networks become very important, because then you want to launch your EMR cluster in such a VPC and subnet which has connectivity to your source database, be RDS, Redshift, or anything else. Okay, so from that point of view, you have to configure your network configuration more carefully when you are trying to connect to a network-based resource like a relational database or a Redshift. So, having talked about network configuration, you can also define cluster capacity. So as I mentioned, your cluster has got master node, core node, and task node, and you can actually define what size you want for each of these nodes. So you can change the size in terms of EBS storage you want, in terms of any other additional configuration you want to do for your EC2 instance, or what size of instance you want to use. You can configure the number of instances you want. You can also go for multi-master, by the way, but in this case showing you one master, and then you can decide number of core or task nodes you want to run. You can run your your purchase option. You can go for on demand, where you pay, okay, I clicked one thing. So you pay for the on demand for those EC2 instances you're launching, or you can also go for spot instances. Okay, so both kind of configuration you can do in terms of cluster capacity when you are configuring the EMR cluster. So having understand the cluster capacity, let's talk about how do I connect to the master node, because as I mentioned earlier that you can SSH to your master node and can actually run local Hive or pick programs over there, or you can also use AWS CLI to submit your task over there. But in order to do so, you have to actually SSH to your master node, and there two things are very important. So your master node has a security group assigned, and your core and task node have got one security group assigned. So this security group over here you need to configure your inbound rules so that the machine from where you want to SSH that has permission to SSH to master. So suppose you want to use your laptop to connect to the master, then you might want to create an inbound rule which says, okay, allow SSH access from your laptop IP to this master. And the second thing, in order to do SSH, you can actually configure a key pair for the master, and using this key pair, you can actually generate the you can use this key pair to do authenticated SSH to your master node. So if you plan to connect to your master, whether you want to use CLI over there to launch the task, or you want to work on Hive or Pig programs or Spark programs installed over there to do some kind of like testing or some kind of work, then in that case you have to connect to the master node, and for that you have to use key pair, and you have to define inbound rule for the security group of the master node. So that was for connecting to the master node. Now, cluster needs to talk to other resources. So like the example I showed you earlier where cluster was actually talking to the S3 bucket in order to read data from there, then it processed the data, and then finally it wrote data back to the S3 bucket. That means cluster needs a permission to read and write from the S3 or a particular bucket in the S3. And in that case, those permissions you can define with the roles. So EMR is assigned certain role, and there's a role which is assigned to the EC2 instances over here, and then this EC2 instance role should be given permission to talk to your S3 bucket. Another example is, suppose you want to read it from DynamoDB, then of course this role should have permission to talk to your DynamoDB table, and those permissions you will define in this EC2 instance profile or the role, so that your cluster has permission to talk to your data sources, whether you want to read it from there or write back to that. So that is from the cluster permission point of view. So having understood these fundamentals, and hope you get some basic understanding about how EMR cluster works and what are different components you have to be careful about, and how you can create a task, orchestrate it, how the program look like. Now we are going to do a workshop. And this workshop, we will launch EMR cluster. And then we have got S3 bucket configure as a source and destination both. Then we'll run Spark code into Jupyter Notebook in interactive fashion. To see how I can read data from S3, do transformation, and write data to the destination. And then we will also launch an EMR task using AWS console to run the same program as a task. Okay, that will give you a good introductory workshop in terms of launching a cluster, doing development with the EMR cluster, and also launching a task like you do in the production. So in order to do this workshop, I have created a workshop and published to our website, aws-dojo.com. I'm providing the link of this workshop in the description box below. And this workshop has got a step-by-step process to do the scenario I just talked about. Now I'm going to walk you through the steps of this scenario and explain what's happening there. And post that, you can run this workshop by your own and learn how you can launch EMR cluster and can do programming with that. So let's move on to the workshop. And this is the workshop. We have already talked about the scenario, so let's start the workshop. And these are the steps you need to perform these are steps you need to perform to complete the workshop. The first step is prerequisite, where it says you need to have an AWS account with administrative access in order to complete the workshop. If you don't have an AWS account, then you might want to use this link to create the AWS account. Next, we create an S3 bucket, and this S3 bucket is actually is used as input output location, and it also has a script folder where I will create the business. I will store the business logic Python file for the EMR task. So you create this bucket, and then you create 3 folders under it: input for the input location, output for the output location, input location for the data file, output for the output location for the data file, and script is for the storing the script or business logic for your task. And then we are using customers.csv file as a sample data over here. We simply upload that to the input location, because this is going to work as a source location for your big data processing. I will encourage that you download this file and look at the file just to get familiar with how this CSV file look like. So once we have configured our S3 bucket, we launch our EMR cluster. So in order to launch the EMR cluster, I simply click on, go to the EMR management console. I want to create a cluster, and we click on the Go Advanced topic because we want to do certain configuration for our requirement. And in this case, it's very important that we select Spark and Jupyter Enterprise Gateway, because we want to use Jupyter Notebook in order to do interactive programming, and this will help in that. And then we are going to use PySpark with Apache Spark framework to do the business logic for big data processing, so we select that as well. Rest of the things I have just kept as it is, and it comes default. Then we move on, and then we go to the cluster composition. We say, okay, let's keep default for my default. Like I want to use uniform instance group. That means I want to have a single instance type for all my nodes. And then I kept my networking to network to default VPC. To be honest, I'm talking to S3, so I don't have any networking requirements. So I simply launch that into default VPC and default subnet. Then we give this a cluster nice name called Dojo cluster, and then we keep the rest of the thing to the default and simply create the cluster. Okay, so when we create the cluster, it will take some time to launch the cluster, and you wait till the message comes that, hey, cluster is ready, and it is now waiting for a task. That is, it's ready, and you can now submit a task. But first we'll not submit a task. First we'll launch a Jupyter Notebook and try to do some interactive programming with Jupyter Notebook, and then we will launch the task. So we click on the Launch Jupyter Notebook. And in Jupyter Notebook, actually, in the same EMR management console, you have got Notebooks menu. You click on the Notebooks. You click on the Create Notebook. You give this notebook a nice name. In this case, I kept it same, Dojo cluster. And then you say, okay, which cluster or which EMR cluster this notebook will work, and that is the same cluster we launched earlier, Dojo cluster. We keep everything to default role, default security group, keep everything default because it's more of introduction, and we simply launch the notebook and wait till the message comes that, hey, notebook is ready for the use. Now let's do some coding into the notebook. So what we do then next is that once your notebook is ready, we simply click on the button called Open in Jupyter. And when you do that, actually, it will launch the Jupyter Notebook. It will ask, okay, what kernel it should load, or what kind of programming language you want to use, environment you want. And I want to use PySpark, right? Because I want to use PySpark with Apache Spark. So I simply select I want to use PySpark. That will open the notebook ID. Now we run the first few lines of code, which is nothing but importing some PySpark PySpark library. So we run that code. After that, we run this second part of the code, which is to get the handle of the Spark session. You get a Spark session because you need Spark session to in order to read and write data. And then we run the next line of code, which is saying, okay, Spark, I want to read from this CSV file, which is stored into this S3 bucket. And this CSV file has got header. That means I want to use header to infer my schema. and yes, I want to infer my schema. I want to generate my schema. So I run this thing, and then this will produce me a data frame, which will actually have data loaded from this customers.csv file. Now we simply want to run something called customers data frame.print schema, because we want to check how does the schema of my data look like. And you can see here it is printing this with the column names and the type of the data into that, and that's how it has inferred the schema, okay, from the header information and data information. Now I want to do a very simple transformation. So I see that it has got customer name and email fields. Rest I'm not interested in, and I just want these two fields. So I simply say, okay, from this data frame, select only customer name and email, and I'm changing my data frame. And then I want to see the print schema again to see if has it changed it. And you can see that when I run the print schema, it says that, yeah, you now have got only customer name and email, nothing more than that. And after that, okay, fine, that's all for my now as a beginner. Now I want to write data back to the S3 bucket. So we simply say, I want to write customer df.write in Parquet format, like in this example, but again, you can use other format like GSV or Avro. And if I'm saying mode is override, that means if there's some file over there, simply overwrite it. And then I'm simply saving it to this output location. And you run this line of code. So all it is doing is simply writing it back to the S3 location. And now if I go to the S3 location and in Dojo data output, you can see that your Parquet file has been created. So this was an example how you can run your code interactively, and that's why you use Jupyter Notebook for development purposes, because you can run your code, you can test the output, you can verify whether the line of code is working nice or not. But once you have done this kind of development, then you say, okay, now I want to convert that into a task, because that's something I want to probably schedule or run based on the event. So that's the next part. We are going to run the task. So in order to run the task, actually, first you remember that when you create a task, first you have to create the program which is going to do big data processing. And for that, actually, what you do, you create a local file on your machine called, say, Dojo EMR task.python file. Python file because it's a PySpark. And we simply write the same code. So it is the same code which you have run earlier in the Jupyter Notebook. Only difference is that in a Jupyter Notebook, I had my my source schema location hard-coded and my destination folder hard-coded. I don't want that. I want it to be parameterized. So what I did, I simply used sys library to simply parameterize it. Say, okay, when I run this task, whatever comes in the argument number 1, argument place 1, I want to use that for my input parameter, and whatever comes in the argument place 2, I want to use that as my output parameter. Fair enough. So having done that, we simply save this whole code into a Dojo EMR task.python file. Then we go to our S3 bucket, we go to the script folder, and we simply upload this Python file over there. So my business logic is now ready and uploaded to S3 bucket. Now we go to the EMR cluster, and I want to launch a task or step. So what you do is that you simply go to the steps tab in your EMR cluster, and then you simply click on add step, and there you simply launch your step or your task. So for instance, I'm doing that. This is a custom jar. I'm running the customer. This is a kind of, you can say, if you have a Python file and you want to run it, you can use custom jar and this command runner jar file to run it. Actually, and then I'm simply passing these arguments. And if you look at this argument, it says my command is, since it is a command runner, so we have to pass a command as an argument to this. So we simply say my command is spark submit. This is my PySpark location, which is 0 argument number 0. This is my source location, which is argument number 1. And this is my output location, which is my argument number 2. And remember, in our code, we're picking the source location from argument place 1 and or number 1, and then destination from the argument number 2. So now you can map this arguments. Now you can map this argument to what I have written in the code over here. Okay. So we simply add it, and then once you add it, actually it will the task or the step will start execution, and then after some time it will complete. And once it is complete, you can go to your output location, task output location, and you can see that it has generated a Parquet file over there. So this was an example how you can create an EMR task, or you can launch a EMR step in order to submit a job. And that pretty much finishes the workshop. The next step is to go and clean up the resources so that you don't incur any cost post this workshop. So that was all for the introduction or beginners tutorial for Amazon EMR. If you like this video, please click on the like button and please subscribe to my channel. There are many other similar workshops and exercises which are published to our website aws-dojo.com. Please explore these workshop and exercises to implement scenario like what we just did and learn about AWS services. We always look forward to your feedback. So if you have any feedback in terms of any suggestions, any improvement you want us to make, or you want us to work on any new content, you have any recommendation about any more tutorials like this, then either you can provide that feedback in the comment section of our YouTube channel or video, or you can also click on the Contact Us tab here and can provide feedback there as well. So we always look forward to your feedback. I promise to come back again in a couple of days' time with another such tutorial. In the meantime, have a nice day and stay safe. Bye-bye.